Good afternoon, everyone, and welcome to the next unit coverage that will continue on our path towards a completed, fully vetted out design of our F1 design, coupled with that of the manufacturing docs required in order to make it at a given, well, if not given, defined cost. Finally, wrapping up in our next lesson with a little lecture on website creation as well as our resume and electronic portfolio creation. Now, up until this point, based off that last video, you've had a lot of time to go ahead and both on your own and in class continue to vet out your Formula One car design. Understand that while it's early yet in this overall process, there are always going to be manufacturing considerations to be considered during the life cycle of a design, whether it's once it's out of the sketch mode and it's now starting to take shape inside of a software, drawing-based software like our product Inventor or any other. You need to start considering how it is that I'm going to make this assembly product work. And not only make it work so that it comes together and performs as intended, but also how this assembly will potentially be manufactured. There are oftentimes incidents where a product may look great on paper and it may even come together in the form of an assembly, but it will not or could not be made cost effectively, if at all. So what we're going to do is we're going to harken back to our cylinder rod assembly that you may recall from our last lesson, involving a pin, very straightforward, but it serves our purpose here. It's a pin that goes inside the cylinder rod support. So it's cylinder rod is essentially within a cylinder rod support, which makes up this assembly. Once again, a typical, if not by way of this size, a typical inspection fixture device, all the same. And again, as we discussed in our last lesson, you've got a couple of components ballooned out here, 1 and 2, listed in the parts list, as well as indicated in the title block. So this is a great example because of its simplicity to go over with our manufacturing docs. Now, our manufacturing docs, as we indicated at the very outset of this project, are to the tune of a bill order of operations, which comes in the form of a spreadsheet, a control plan, which tells us how we're going to inspect it in the form of a spreadsheet, a cylinder rod assembly manufacturing process flow, which is a PowerPoint, and finally, a BOM reference, and for that we're looking at it. Basically, a bill of material is essentially, unless you've got a type of accounting system, or rather document control system, that speaks to something other than the print or over and above the print, our print is basically our bill order of materials. The bill order of materials as they exist on an assembly, again, is just that of the two items that come together to form the assembly. The bill order of material on a rod support, in this case, is something different. It involves the material required to manufacture this part, same as in the case of the rod, in that it requires the material required to manufacture this part. Now, understand that with respect to this lesson, we are going to be covering four items, and it's all going to revolve around this cylinder rod assembly. They are, once again, the bill order of operations, the bill order of materials, the manufacturing process flow, and the control plan. And all of these particular manufacturing documents that support our drawings are coming to you, or will be developed by you in the end, but coming to you in the form of a template file that basically speaks to this sample file. And it's all Microsoft Office Suite applications. So we're going to start off with the BOO, or the bill order of operations, for this particular assembly. Now remember, this assembly and these two individual components are supported by these manufacturing docs in their entirety, and I'll show you how. In the case of the BOO, we have three tabs, one for each for the two components and one for the assembly. Take a look. It's a spreadsheet, and it's a template file. You can use the one that I gave you as a reference here verbatim, or you can use the template file that's in Google Classroom that just has these fields blanked out, save for the formulas. And you'll notice that on the assembly level, and we'll start with the assembly and work our way down into the components. On the assembly level, actually, let's go to the components first. Scratch that. It'll make more sense explaining it this way. So you have component 1 and component 2. And if you remember, component 1 was the cylinder rod support, and component 2 was the cylinder rod, just as indicated in these spreadsheet fields. Now, what's very important, let's go in numerical order. CMP 001 has its part number and description defined. The rest of this is brand new to you, but just know that this is what in industry is known as the bill order of operations. What does that contain? That contains the part number of the vendor's item that we're going to buy raw, if you will, or blank, in order to satisfy our machining requirements of this part. Now, as it just so happens, with Grainger, there was a rectangular stock item that's 1.5 inches by 2.5 inches by 1 foot that's of 1018 steel under that part number. So I have a description or an item number and a part number. Now, that is our minimum size stock that can satisfy machining that particular cylinder rod support. It comes in at $55.95 and it's from Grainger. Is that all of our costs? No, because we have to incorporate all of the costs to manufacture that part. Now, this is obviously brand new to you. Up until this point, you haven't been exposed to the manufacturing side. That's why we're working through this step by step to capture this basic assembly. With the cylinder rod assembly, we go back, or the cylinder rod support. If you look at this particular part, and you recall, it was just a horseshoe-shaped part, 5 inches long, ultimately 2.5 inches high and 1.5 inches in depth. Very much satisfied here, and then some. In terms of the 1.5 by 2.5, the 1 foot is going to be our cut length, and it'll allow us to purchase in the process multiple items. But we do need this minimum stock size in order to manufacture one part. Right now we're looking at an operation quantity of 1. We need to saw cut it to length because the stock comes in with 2 of the 3 dimensions defined, the 1.5 and the 2.5, but we need to make sure that we cut the foot down to 5 inches. So you can effectively get 2 parts out of this 1 part stock item. Then you rough mill it, machine it to size, you deburr it, clean it, inspect it, close the work order out. Actually, you saw cut it to length, and then you rough out the core and machine to size. Machine to size basically is saying we're gonna pop in the holes. Because remember, there's 2 holes that go in here, and sorry for the shorthand, but that's basically what that's speaking to. Rough out the core and saw cut the length are the 2 steps required to remove this material after it's cut the length. All right, you know, we're just capturing the main steps in machining this part. Categorically, based on our estimated hours at a flat rate of $15 an hour, our operation costs read from top to bottom with respect to each one of these item descriptions. So you got 6 steps to manufacture the part. Even the auditing side, where they just close the work order, the inspection, the clean, all costs money. They may be fast operations, as you can see here, with respect to percentages of an hour, but every hour costs $15. That's a standard rate. And by the time you add up all these with the material, this formula right here captures D4, the material stock item, along with E7 through E12. Very simple formula that captures all your costs. All right. The same goes for the rod. There's no difference here. The rod is 1018 also. It's 1.1/8 inch diameter by a foot long, meaning we have a rod that finishes off at 1 inch, but look at the tight tolerance. We can't buy it at 1 inch. And it's 5 inches long, as is the cylinder rod support. We can buy it at a foot length, and we can buy it as a round bar stock at 1.1/8 inch diameter, and that costs us $10.43. Much like the rod support, we could machine 2 of these right now out of 1 bar stock purchase, but right now we're just looking at capturing 1. Similarly, you have the saw cut off, machine overall length, deburr, clean, inspect, close work order. All right. So machine OD and length means you're machining it down to that 1 inch and bringing it into 5 inches. All these cost money. These are estimated hours, and these costs coupled with the raw material costs is this amount of money. So you look at $44 and $119, and that rolls into our assembly costs right here. Now you wonder, well, actually it's broken down into the individual components. Submaterial, the 4418 is item number 2, and 11970 is item number 1. They add up, because there's no raw material cost with the assembly. They add up along with the costs it takes to put this thing together. Now remember, this guy actually is flush welded around at each end, just to lock that pin in place. The pin can't go anywhere in 2 directions. Now you got to take it out of the third. And with those costs added in to weld, deburr, clean, and inspect, even though it's minimal after that, it's still money. And these labor costs coupled with these 2 material costs give you a grand total of $192 approximately estimated at this point. Later you can get actual hours out on the machine floor to determine the actual cost. But approximately $192 to make this entire assembly from start to finish. Why is this valuable? As you can imagine, 1, you need to ensure that you can make it within the realm of your workplace. 2, you have to make sure you can afford to make it to satisfy the cost in which you're going to sell it for. Okay, so that's the bill order of operations. The next item is the control plan. Control plans at the high school level, secondary school level, don't really spend a lot of time with, other than to point out to you that this is something that's broken down similarly by component and assembly, but it speaks to no longer how much costs and what order of operations are associated with those costs to manufacture the components and then ultimately assemble the item. This speaks to how I inspect everything that I'm producing or establishing in the way of cut features on the component and assembly level. In other words, it's great that you're telling me what order to perform the operations in order to create these components and assembly, but now how do I verify that those dimensions by way of these given operations were accurate? accurately performed, I should say. Well, this is how, and I've highlighted in the interest of time, and we'll go back into this more detailed on a one-on-one basis. But really, for the most part, I pretty much captured here the same operation, only by way of the description of what it is that the feature establishes. And then I highlighted the fields that are negotiable. We know that we're going to always have a sample size of 1, and a reaction and control plan is a little beyond our scope, as well as our characteristics and special class characteristics. But we do know that we need to establish a machine device for manufacturing. These are all going to be manual performed inspections. We also know that every process order of operation has some type of feature established. In our case, with respect to the cylinder rod support, we have overall length, overall height with counterbore hole and bore diameter. These features are then transferred here into these fields, and you notice where they're coming from are 5, 2.5, 1.5, quarter-inch hole with 3/8 counterbore. These are all holes that are placed in component 001 or our rod support. Remember, we have counterbore holes here, we have the 1-inch bore, we have the length, we have a height, we have a width. All those dimensions align with these callouts, along with a given tolerance and a method of inspection. This is important because we could talk all day about how we have to establish certain given lengths and bore sizes and so forth, but we need to know how we're going to inspect them and how often. That's across the board. Similarly with 2, only far less to concern ourselves with. We have a cut length, overall length, I should say, and we have a diameter. Because the diameter of all the features so far decided upon, that's the only one that goes to such a tight tolerance as 1/1000th of an inch. And so in turn, that jumps from a micrometer being required as opposed to a caliper. Lastly, we go to our assembly. And really the only operation that involves any type of inspection is the overall weld of that pin trapped inside this assembly. You have to confirm that those two surfaces are flush. Well, the way you do that is you measure that 5 inches after the fact, and that can be done with a caliper. So you see, this control plan is invaluable in establishing how we're going to inspect everything that we've determined to be a dimension on our drawings. Okay? Next thing, our manufacturing process flow. This is nothing more than a PowerPoint that basically follows every step in our order, or in our bill order of operations in terms of flow. So flowchart software is a nice to have. A must have is a PowerPoint, with the ability to, just pop in the order of operations numbers by their descriptions and showing how the process flows in manufacturing. Sometimes operations happen concurrently, and so you have to make that distinction of how the process flows for the assembly, for each component item as well. So we'll look at the cylinder rod again, as in the case of the bill order of operations and in the case of the rod support. They both start out with a material call out. They go to saw cut, machine, deburr, ultrasonic clean, inspect, down to, and here's where you have a decision. And this is where the flow chart comes in handy. If you remember from our boo, it goes right from clean to inspect, and then we just close the work order out. We don't have a decision here. We just assume, we're just laying it out there that you're inspecting it. What if it doesn't pass inspection? If it passes, there's nothing more to concern ourselves with. We close the work order just as the boo entails. If we reject it in inspection, Then we have to send it to the material review board, who in turn maybe re-inspect it or make an allowance for what's non-conforming about the part. This is why we have process flow charts right here. So that basically covers the bill order of operations, the control plan, the manufacturing process flow, and of course we led off with our bill order of materials, and that is encompassed in the BOO as well as on our assembly drawing. I hope that gives you a good introduction to the manufacturing documents required, and I'll take any questions at this time. The team, Nick and Jackson, you guys please move on to this section on the bill order of operations and address the issue that you and I, or the three of us rather, talked about the other day with respect to flipping those two processes around on your body design, manufacturing ops. And anybody else, any questions? Again, wanted to lay this information out there. This is reference material that's out there as well, and I think that should cover it. Thanks again for your attention, and I'll follow up with everybody's teams right after this recording. Thank you.